Hello friends, today we shall discuss the inverse Laplace transform. What do we mean by an inverse Laplace transform? Up till now what we did, we have found the Laplace transform of certain function which was function of f of t, and after finding out their transforms, we have found their transforms in terms of f of s. We have found by using fundamental definition number 1. We have also found the Laplace transform by using the properties of Laplace transform. Now, we shall study the reverse way, inverse procedure. If now f of s is given to us, find out f of t. So what is the definition exactly? If Laplace transform of f of t is f of s, then inverse Laplace transform of f of s is equal to f of t. Very simple and fundamental definition. If Laplace transform of f of t is f of s, capital F of s, then inverse of capital F of s becomes small f of t. For example, what is Laplace transform of 1? It is 1 by s. Laplace transform of 1 is 1 by s. In view of this, therefore, inverse of 1 by s is equal to 1. Inverse Laplace of 1 by s is 1. Laplace of constant k is k by s. Therefore, inverse of k by s is equal to k into 1. Laplace of 1 upon s minus a, Laplace of e raised to power at is 1 upon s minus a. In view of this, the inverse Laplace of 1 upon s minus a is equal to e raised to power 8. Laplace of e raised to power minus at is 1 upon s plus a. In view of this, Laplace inverse of 1 upon s plus a is equal to e to the power minus 80. Laplace of sin h of at was a times or a upon a square plus a square. Therefore, inverse of a upon a square plus a square is equal to sin h of at. I'm sorry, it should be minus in the denominator. Otherwise, it would be sin of it. A upon a square minus a square. Inverse of this is sin h of it. If we divide this by a, therefore L inverse of 1 upon S square minus A square is equal to 1 by A into sin h of 80. Laplace of cos h of 80 is equal to S upon S square minus A square. In view of this, L inverse of S upon S square minus A square is equal to cos h of 80. Laplace of sin of 80 is equal to A upon S square plus A square. In view of this, inverse of not A upon A square plus A square, perhaps only 1 upon A square plus A square will obviously be equal to 1 by A times sin of 80. Laplace of cos of 80 is equal to S upon S square plus A square. L inverse of therefore S upon S square plus A square is equal to cos of 80. Laplace of t to the power n is equal to n factorial upon s to the power n plus 1. Therefore, inverse of 1 upon s to the power n plus 1 is equal to t to the power n upon n factorial. Factorial in terms of gamma, it is also equal to t to the power n upon gamma of n plus 1. Because factorial n is equal to gamma of n plus 1. So these are the some basic fundamental inverse Laplace transform. You must know all these standard formulae. So we have revised some formulae. Inverse Laplace transform. Basic fundamental. Using all these standard definitions, what would be Laplace transform of t upon s plus 7? It is of the type 3 is constant, so it is 3 times L inverse of f of s is s plus 7. So it is equal to 3 times e to the power minus 70. Because Laplace of e to the power minus 70 is 1 upon s plus 7. So it is 3 times s plus 7. That is how we determine or use the basic definition. Laplace inverse of 5 upon 3s minus 2. This is equal to 5 times L inverse of 1 upon 3 times s minus 2 by 3. that is further equal to 5 by 3 times L inverse of 1 upon S minus 2 by 3. So that reduces to 5 by 3 times e to the power 2 by 3t. If you take the Laplace transform of this function, 5 by 3 times e to the power 2 by 3t or 2t by 3, then its Laplace transform would of course equal to 5 upon ds minus 2. Next, that was first example. This was second. Laplace inverse of 1 upon s square minus 16. It is of the type 1 upon s square minus a square. 1 by a sin h of 80. So it is equal to, it is 4 square, therefore it is 1 by 4 times sin h of 4. L inverse of 3 upon 4s square minus 25. Let us reduce this into the standard form. Standardize this. So it is 3 times L inverse of 1 upon, should be mentioned in s square minus a square type. So take out 4 common. So it is s square minus 25 by 4. So it is of course equal to 3 by 4 times L inverse of 1 upon s square minus 25 by 4. 25 by 4 is square of 5 by 2. So by definition it is equal to 3 by 4 is constant outside. It is equal to 1 by a. A is 5 by 2. So 1 by a is 2 by 5 times sin h of 80 pi u t by, so it is 3 by 10 sin h of phi u t by. That is how we find or determine the inverse Laplace transform. Some more examples. Now, we shall find out the inverse Laplace by using the properties. Inverse by using first shift property, inverse by using the second shift property. What was the first shift property? First shift property was if Laplace of f of t is f of s, then Laplace of e to the power at into f of t is equal to f of s minus. Now it is plus, then it is minus. If it is minus, then it is plus. We have seen this property. It was called as first shifting property, or finding out the Laplace transform when f of t is multiplied by e raised to power plus minus 8. So, in view of this, therefore, inverse of this f of s minus plus a is equal to e raised to power 80, e raised to power plus minus 80 into f of t, or e raised to power plus minus at. What is f of t? It is L inverse of f of s. F of s, capital F. That means if the given example, given problem is of the type f of say s minus a or s plus a, then its inverse can easily be determined by using this property. Must understand this property. So, let us find out example. Obtain one upon s plus 5 cube f of s. f of s is 1 upon ब्रैकेट में s plus 5 का क्यूब. ये f of s ये s plus 3 के फॉर्म में दिया हुआ है. This is of the type f of s plus 3, 1 upon s plus, sorry, f of s plus 5 के फॉर्म में है, s plus 5 के फॉर्म. So it is f of s plus 5, 1 upon s plus 5 का क्यूब. तो f of s क्या होगा? 1 upon s plus 5 की जगह पे s क्यूब. So using this inverse first shift property, this is equal to, see here, e raised to power minus 5t into L inverse of 1 upon s cube. This f of s minus a, it is f of s plus 5. This is 1 upon s plus 5 cube. So f of s would be 1 upon s cube. Replace s plus 5 by s simply and take its inverse. So this is equal to e raised to power minus 5t, and inverse of this is t square by 2 factorial. 2 factorial is 2. So that is how we use the inverse first shift when f of s is of the type f of s minus a or f plus a. Inverse by second shift property. Second shift property क्या थी? If f of t is equal to f of t minus a when t is greater than or equal to a, and it is equal to 0 when t is less than a. If there is a function defined something like this, then Laplace of this capital F of t is equal to e to the power minus as into f of s. Therefore, inverse of this e raised to power minus as into f of s is equal to capital F of t. But what is capital F of t? It is equal to f of t minus a when t is greater than or equal to e, t is less than a. We have also seen this type of function is also denoted by f of t minus a into u of t minus a. So when do we use this property? If and only if the function whose inverse is to be determined contains an element of the type e to the power minus as. एग्जाम्पल में यदि e to the power minus as मल्टीप्लायर है और बचे हुए फंक्शन f of s का इनवर्स क्विकली निकलता है, तो हम ये डायरेक्ट वन स्टेप प्रॉपर्टी से इसका इनवर्स सिंगल स्टेप में निकाल सकते हैं। फर्स्ट शिफ्ट प्रॉपर्टी क्या थी? यदि फंक्शन एफ ऑफ एस माइनस ए के टाइप का है या एफ ऑफ एस प्लस ए के टाइप का है, तो उसका फॉर्मूला था e टू द पावर ए टी इंटू एल इनवर्स ऑफ एफ ऑफ एस। एफ ऑफ एस माइनस ए प्लस ए में से एफ ऑफ एस डिटरमाइन करके उसका इनवर्स निकालते थे। हियर इफ द फंक्शन इज मल्टीप्लाइड बाय e टू द पावर माइनस ए एस एफ ऑफ एस, ऐसे एग्जांपल्स में हम सेकंड शिफ्ट प्रॉपर्टी कैसे यूज करेंगे? ये एफ ऑफ एस का लैप्लास निकालेंगे एफ ऑफ टी, और ये एफ ऑफ टी को एफ ऑफ टी माइनस ए यू ऑफ टी माइनस ए से रिप्लेस कर देंगे। हो गया। सी हियर आई एम टेकिंग एन एग्जांपल। Let's take a very simple example. Inverse of e to the power minus pi s upon s square plus 1. देखो यहां पर मल्टीप्लायर है e to the power minus pi s, e to the power minus as के फॉर्म में है, तो a की वैल्यू क्या है? यहां पर पाई है। e रेस टू पावर माइनस as मल्टीप्लायर है, इसलिए हम यहां पर सेकेंड शिफ्ट प्रॉपर्टी यूज करेंगे। e रेस टू पावर माइनस पाई एस को छोड़ दिया तो बचे वाला फंक्शन क्या है? एफ ऑफ एस 1 अपॉन एस स्क्वायर प्लस 1। ये है एल इनवर्स ऑफ e टू द पावर माइनस पाई एस इंटू एफ ऑफ एस के टाइप का। तो एफ ऑफ एस क्या हुआ यहां पर? 1 अपॉन एस स्क्वायर प्लस 1। देयरफॉर एफ ऑफ टी क्या हुआ? एफ ऑफ टी यानी एफ ऑफ एस का इनवर्स 1 अपॉन एस स्क्वायर प्लस 1 का इनवर्स लैप्लास ट्रांसफॉर्म। कौन से फंक्शन का लैप्लास ट्रांसफॉर्म 1 अपॉन एस स्क्वायर प्लस 1 है? साइन है, साइन टी। सो एफ ऑफ टी हुआ साइन टी। Therefore, by inverse second shift property, L inverse of e to the power minus pi s upon s square plus 1 is equal to f of t minus, मैं फॉर्मूला लिख लेता हूं पहले। यहां पर a की वैल्यू पाई है इंटू यू ऑफ टी माइनस पाई। ये एफ ऑफ टी है, तो एफ ऑफ टी माइनस पाई है, साइन ऑफ टी में टी की जगह पे टी माइनस पाई इंटू यू ऑफ टी माइनस पाई। साइन ऑफ टी माइनस पाई माइनस टाइम्स साइन ऑफ टी इंटू यू ऑफ t minus pi. Very simple. The function must contain e raised to power minus k as a multiplier. Then and then we can use this property. Now, that was the second shift property. Now, inverse Laplace by derivatives, third property. by differentiating f of s, we shall find out the inverse. How? Inverse Laplace transform by determining inverse of their derivatives. See here, if Laplace transform of f of t is f of s, then we have seen the multiplication by t property. Then Laplace transform of t into f of t is equal to minus 1 raised to power 1 into dds of s, f prime of s. This was the multiplication by t property. Now taking inverse of this both sides, we have, what shall we have? Therefore, L inverse of minus f prime of s is equal to t into f of, or in particular, L inverse of f prime of s L inverse of f prime of s is minus t into f of t. This is very nice property. It is inverse of multiplication by t property. The example based on this property is often asked in the examination. If the example f of s, if f of s is of the type, which type? Inverse tangent, inverse tangent, inverse cotangent, logarithmic. If f of s is of the type cot inverse, tan inverse, log of something, f of s, then we use this property. See here how nicely we use this property. Shall see one example and then we shall stop. Inverse of cot inverse of s. While solving an example, finding out Laplace transform, we have seen that Laplace transform of sine of t divided by t by using division by t property. The Laplace of sine t by t was cot inverse of s. So, now inverse of cot inverse of s. Now f of s is here. Where? Here f of s is cot inverse of s. Therefore, L inverse of, the formula is f dash of s is equal to minus p into f of t. Now, therefore, L inverse of f dash of s means dds of cot inverse of s is equal to minus p into f of t. Therefore, L inverse of, what is the derivative of cot inverse of s? That is equal to minus 1 upon s square plus 1 is equal to minus t into f of t. Or therefore, L inverse of 1 upon s square plus 1 is equal to minus, sorry, now I have multiplied both sides by minus 1. It is equal to plus t into f of t. Now what is inverse of 1 upon s square plus 1? Obviously sin t. Sin t is equal to p into f of t. Therefore, f of t is equal to sine of t upon t. Just use this property, multiplication by t property. Inverse, one more example, little short example we shall see. L inverse of, now we shall see logarithmic function. L inverse of log of s plus b upon s plus a. A and b can any constants. So here, where? Here. What is f of s? It is equal to log of s plus b upon s plus a. We know that, what we know. L inverse of f dash of s, dds of f of s is equal to minus t into f of t. Therefore, L inverse of dds of, what is f of s? Log of s plus b upon s plus a is equal to minus t into f of t. Now just determine the simple derivative of log of s plus b upon s plus a. dds of this is further equal to dds of, number 1, log of s plus b minus log of denominator is equal to minus t into f of t. Now, differentiate this. L inverse of dds of log of s plus b is 1 upon s plus b minus s plus a is equal to minus t into f of t. This has been completely standardized. L inverse of 1 upon s plus b is e raised to power minus bt minus e to the power minus at is equal to minus t into f of t. Therefore, f of t is multiplying by minus 1 also. E raised to power minus at minus e to the power minus bt upon t. That is how we determine the inverse Laplace transform. Today we shall see, we have seen some basic fundamental formulae. Then we have also found the inverse Laplace by using the properties of Laplace transform. So thank you very, very much. Thank you.